I'm extremely excited to welcome Niraj Mathur, who I met with last year in Canada at Venture Lab. And a lot has happened in that past year. Niraj, before we jump into it, for those who may not be familiar with you or Blumind, can you give us just a high level introduction of yourself and your background?
Great to be here and chat with you again. So my background is in the semiconductor industry. Started off as a hands-on chip designer, working on all kinds of ASICs, data center, and other applications. Then moved over to engineering leadership and marketing and business development functions as well. Worked for large companies and did a couple of startups along the way as well. And started off. Ended up at Rambus, a Bay Area-based company building data center products, and noticed this massive avalanche of data that everybody wanted to move inside the data center between servers and across data centers, and really struggled to understand what was causing this. And was it people surfing the internet more, downloading, streaming more movies? Turns out. It was all of that, but more than that, it was this new exciting workload called machine learning or AI, and this is what was really driving up the demand for moving data because it's extremely data hungry method of solving problems. So right around that time, I met my co-founder John, and we started Blumind. Roger Levinson, our third member of our leadership team, joined in 2021. And we've been going at it ever since. Very simply put, we're building the world's most energy efficient machine learning inferencing processors. That's what we're all about.
Awesome. Well, a year ago when we met at your headquarters in Venture Lab, the team had just got the test chip back. A lot has happened since then. Can you share with our audience some of the major updates?
Yeah. So they've been we've done 3 generations of test silicon so far. First, just to take a step back, the way in which we're approaching machine learning processing is very different than the way everyone else is today. Okay. Most people are looking at machine learning inferencing as a compute problem, and hence deploying our traditional compute tools to solving it, right? Basically, von Neumann based computer architectures. We're continuing to evolve those, improve those, optimize those to solve this new workload. The challenge is this workload is unlike any human written sequential code, right? It's extremely orthogonal to that. It's massively parallel, very, very compute intensive. And therefore, using the old toolkit for this workload leads to tremendous inefficiencies, and a completely new way of looking at the problem is really what's needed. So that's what we've done is we've kind of wiped the slate clean and said, okay, what if we were to assume there were no computers in existence today, and we're developing from the ground up machine learning optimized processor architecture. And that's really what Blumind is trying to do. So our architecture looks very different than anything else that's been deployed to date. So as such, it is a very heavy lift to get there. It takes a good 3 to 4 years of R&D, and we're coming out of that now. So we've done some foundational development work to prove out the primitives that are the basis of our architecture, prove those out in silicon, and then subsequently leverage those to develop a product. And that's where we are right now is developing our first commercial product, which is targeting ultra low power, like single digit microwatt AI for time series sensor processing. So that's what we're developing now. We did our first kind of prototype test chip for that product late last year. That has been very thoroughly tested now. There are a few kinks that we're ironing out. That's going back to fab for a second rev in about 2 weeks. So we'll have updated silicon in the summer to sample to our lead customers. So that's where we're at right now.
Well, definitely some exciting times, and you're a man of tremendous conviction. Last time I was up there, because I want to go a little bit deeper on some of the differences in how you're solving the problem versus really the rest of the industry. Because one of the things that really struck me is that you and the team at Blumind are going all in and running towards analog compute when a lot of other companies are running away from it. Um, can you talk to us and remind our audience why you believe so strongly, and share anything that's happened in the past year in this approach?
Yeah, and by the way, I'll correct one thing that you mentioned. It's kind of a new development. The world is no longer running away from analog compute. In fact, one of the trends I've observed very strongly, even over the last 6 months to a year, is that more and more people are recognizing that something different needs to be done. We need to have an alternative architecture for machine learning processing, optimized uniquely for machine learning, in order to reap the efficiency and performance advantages that traditional compute just cannot offer. So I will caveat what you said with that. This is fairly recent, right? When we started out, we were we were one voice speaking very differently than the crowd, but now we hear more and more voices kind of reaffirming our approach. That has been very gratifying to see, just even in the last year. And you know, talking about the differences, how we're doing things differently. So firstly, one major trend that is playing out, which on the surface looks quite reasonable, is you need to build domain specific optimizations to get the next level of efficiency and performance. So building general purpose CPUs and GPUs just won't cut it for many applications. Okay. There will be still a large body of applications and use cases that will be served well enough with general purpose processors, but there is an increasing number of applications that really need that extra efficiency and performance. So those applications are fast emerging, especially as the complexity of the models increases and as AI more and more starts getting deployed to solve, problems that were traditionally solved by, legacy algorithms and software. A lot of those are transitioning over to machine learning. So for all those reasons, the need is rapidly increasing. The way in which we're different in many ways, as I mentioned earlier. This is a completely new way of looking at machine learning processing. But I'll highlight some key salient points. Number one is we believe that the network interconnectivity, being controlled by an instruction set, which is typically generated from compiled algorithm or software, that leads to a lot of inefficiencies. So we have built, a data flow and pathways in our silicon to actually define the network connectivity on the chip itself without having to interject and be orchestrated by a compiled instruction set, right? That's number one. Number two is doing computations and moving data in a digital fashion is extremely inefficient, as your viewers may be aware, right? Most computers are binary, arithmetic based, and they're digital compute and digital logic is constructed with many like a group of many binary operations, transistors being used as ones or zeros, right? Fundamentally, and then using a lot of those primitives to build higher order functions, arithmetic functions, logical functions out of that. What we've done is said, okay, that again, yes, it creates this layer of abstraction, which is nice when you want to do functions of very big scale. You want to make things easy to implement and roll out. So all of those are advantages that approach has. However, you leave a lot of performance on the table. So transistors can do way more than just be binary switches, right? So we use the same transistor devices, but we exploit the device physics of those devices to do way more than just be a one or a zero. What we are able to do is using the same transistor perform multi-bit multiplication, but firstly storage and multiplication of activations and neural network weights using the same transistor, fully exploiting the device physics of these components. So that yields to tremendous advantages. Components and functions that take hundreds of transistors, thousands of transistors, and memory to implement can now be condensed into a single device, right? And that creates massive efficiencies for our approach.
Very cool. And actually, as a further validation of what you were talking about before, that the world's going more and more in the direction of analog compute, there was some massive news recently about Encharge and the funding that they've received. How do you view that? Does that validate more and more your approach, and or does it enter in another competitor that makes it more challenging for you? And I guess largely, how do you differentiate what you're doing versus Encharge?
Yeah, so I think it's a great validation. This space we're at the first innings of solutions like this. It has a massive, massive market with many companies that will be successful here, okay, over the long run. So in that respect, any competition that is successful um, with a solution in this space is absolutely a positive for this frontier of innovation that's playing out in the industry. So I welcome all those all those steps forward, even by our competitors. Now, having said that, as I talked about, domain specific nature of what we're doing, particularly when you look at the edge, things get even more fragmented. If you're building products for the data center, that is a very homogeneous architecture, right? At the edge, things get very fragmented because the chip you're building for an automotive application or a drone application or robotics application, even if they're performing similar functions, can look very, very different just by nature of the environment these devices operate in. So that creates a lot of challenges, but it creates a lot of opportunities as well. What we have chosen to focus on is really deliver reliability, accuracy, and scale to our customers and the applications we're targeting. And it is incredibly so. All the benefits I just described of everything we're doing come with a set of tremendous challenges as well. So it's not straightforward to do the level of innovation we're doing, and it takes a extremely skilled and talented team. It takes a lot of grit and perseverance because you're going against the grain here, definitely for what the rest of the industry is doing. So it is a very heavy lift to get solutions like these developed into the market. There's a number of teams trying hard. I find it great that companies like ours are getting the interest of investors. We recently closed a Series A round as well, and this is just validation that these approaches deserve to come to fruition.
Well, and you know what? Congratulations on the Series A, the 20 million Canadian, major milestone and a testament to what you and your team are doing. Now that you and Roger and other leaders have secured that, what are you planning to do with that capital in order to grow the business?
Yeah, it's a good question. We have three main objectives for this fundraise. We've got number one, to commercialize our first product, the BM110, which is at the prototype phase right now. We've got a number of lead customers very interested in taking this to volume production, and that's a great feeling, but also unsettling because our customers are kind of pulling us and saying, "Hey, we want to get this out. When can you deliver samples? When can you get to high volume production?" So this fundraise is definitely going to help solidify our position there, and really get this product to high volume production. That's number one. Number two, we're running a whole bunch of POCs demos and so forth to engage new customers and explore new use cases with this first gen solution that we're commercializing. So we'll continue to do that and accelerate that work actually. And number three is also invest in our roadmap. So we do have a rich follow-on roadmap of products that we want to execute on. So we'll be doing some pathfinding discovery work on the next gen products as well. So all of that will be accomplished with this fundraise.
Well, I like the fact that you mentioned customers multiple times because that's where revenue comes from. Without naming specific potential customers, can you also talk a little bit about you spoke about the importance of domain specific architectures. What is that market? Because you guys have had such a focused effort in market penetration. What's the overarching market that Blumind is looking to dominate in?
Right. So, we're seeing machine learning creeping into always on, always monitoring type of use cases. So even something that you may consider as a solved problem, something like a wake word detection, right? So the user issuing a command to wake up a device, right? Whether it's a TV, whether it's a remote control, whether it's your Ring, whether it's your smart glasses, whatever the device may, or an IoT sensor hanging on the ceiling, whatever the case may be, you may think that's a solved problem, right? Because we have devices that do this. Our cell phones respond to our voice commands today. Alexa pucks sitting in our living rooms do the same. The challenge is doing this for a power budget that is as close to zero as possible, because the devices I described that are running off a battery, and in many cases a tiny battery, right? You have wearable devices, not the one I'm wearing, but you have other vendors that have wearable devices that last many weeks on a single charge. They don't currently have always on audio interfaces because of the battery challenge. So for all those devices, once you apply the lens of energy efficiency to unleash this audio interface, which in many cases is a very natural way to interact with these devices, then your number of solutions that can support you dwindle very rapidly. Okay, and this is exactly one of the use cases we're targeting with this first product, is to deliver single digit microwatt level AI for those always on applications for voice interfaces. So that's an example of the kind of application we want to target with this.
Very cool and very exciting. Can you share with us over the last 365 days a time or an event that has left you feeling most energized and excited about what you guys are doing?
Well, yeah, absolutely. We were at CES this year. This was our first time at CES in January of this year. And we were a bit tentative about it because we don't have a product in high volume production yet. So we're a bit tentative about our presence there. But I got to say, the event was just fabulous for us. We got a ton of interest from companies that we had never met before. So it was a great ground to meet folks that we wouldn't have normally bumped into, and just a massive amount of interest around this AI everywhere kind of theme. We met a lot of folks building smart wearable devices, medical devices, IoT devices, robots. All of these guys need to run AI on device. So that was it. Kind of re-energized us those few days at CES, and actually a lot of the conversations we started there are still going on, and we made a lot of friends and a lot of connections at that show. So that, I would say, was definitely a highlight for us so far this year.
Well, I guess anytime you can leave Vegas more energized than when you went, it's a win. So, um, you know me, I always like to paint a very real picture. And oftentimes these interviews can just be a highlight reel that's unrealistic. Similarly, over the last year, has there been a defeat or a demoralizing time or event that actually now coming up to date, you realize has been fundamental in helping to shape Blumind.
So yes, there's a great example of that recently at that same show at CES. We had set ourselves a very aggressive objective of having a live demo on the floor at CES, and our chip had just come back from fab, and we hadn't got the full demo working, and we decided to try it anyway. So I lugged around our big evaluation kit, a suitcase full of that equipment, to our booth in the basement at CES, and our engineers were still trying to log into the setup and get the demo fully working. There was no Wi-Fi at the show, which is something we didn't think was going to be the case. There was my cell phone was down to 1 bar. So long story short, we were not able to get the demo fully working on the floor, and subsequently we found out why. We had some kinks. We had a bug in the chip that was preventing that from happening. So yeah, that was certainly a bit of a setback. We were planning for the best case of having a fully operational chip on the first pass for this user application. However, what came out of it, as I said earlier, we still had a ton of interest just being there and getting the word out on our technology and the kind of products we were building. And our lead customers, thankfully, very, very knowledgeable, sophisticated folks in this place, totally understood the magnitude of what we're trying to do, and are still working with us to get this to high volume production. So yeah, that's a little bit of some reality to folks, to your viewers. It is a very difficult road. Semiconductors are a very unforgiving and challenging domain to work in. But people around, customers, investors, partners are just phenomenal folks. So we're not doing this alone. We've got a great ecosystem supporting us to make this successful.
You mentioned that is the investment community as well. And I know you well enough to know that you weren't just seeking any investment. You wanted to have the right partners. Can you walk us through the qualities that you were looking for and maybe lessons you learned in pursuing that Series A funding?
Yeah, absolutely. And it's a very important to get the right investor, especially for a deep tech company like ours that requires an inordinate amount of patience and understanding to really see this through. It's not for the faint of heart. So what I was personally looking for is an investor that has the technical depth to understand uh, better than most people what we're trying to do, understand our solution, understand the challenges that come with it, and understand deeply the objectives we've set for ourselves, and really be in a position to help us, critique that and help us and make the end outcome better for the company. So that was really front of mind. And these investors are not easy to come by, as you can imagine. We're working in the semiconductor space, innovating at the transistor level. Not a lot of investors have that kind of depth, right? This is kind of a niche area. So that's it's tough to find these folks, but we found one. So Cycle Capital, that led our round, actually one of their principals is a technologist and used to be an analog chip designer back in the day, and has built companies that build chips very much like ours. They also invested in GaN Systems, which was acquired last year. So they've been through that journey before as well. So they came to our lab and looked at our technology very deeply, hung out with our engineers, and had very deep discussions about where we were going. And even in the due diligence phase, came to us with ideas and new perspectives, which made me very convinced that, okay, this is the kind of investor we want to have on our team. And BDC Capital provided the same kind of support. Fusion Fund, who's already an investor, reparticipated. So those are the kind of folks we look for, as folks that really understand what we're doing and the customers we're trying to serve.
That's awesome. And presumably part of the growth of the company involves expanding the team. It appears from the outside like a lot of the growth has happened organically through friends, family, network hiring. As you accelerate the growth, what strategies are you and the team there planning on implementing in this extremely difficult market?
Yeah, it's a great question, and we don't have all the answers yet. So we're still finalizing a hiring plan. Certainly, for the objectives we want to achieve with this new funding, we will have to expand the team. We want to be very careful about who we bring into the team. We want to bring in the best people we can find, right? Because that's really going to directly impact what we're able to do going forward. So we are working with some selected recruiting partners. Our investors are helping us a lot as well. Try and find the right people out in the industry, and yeah, it's just a constant process of improving our recruiting process to get the best people in.
Awesome. Well, Niraj, I hope to make this an annual event. And assuming that we're talking a year from now, what do you envision that we're talking about a year from now as far as Blumind's journey?
Well, we want to have our chips in customer applications and use cases. So more than talking to me, I hope you'll be talking to some of my customers and getting their feedback, right? That would be phenomenal, and I think we'll be able to do that next year for you.
Awesome. Well, I can't wait. I am so incredibly happy for you and the entire Blumind team's success thus far, and look forward to doing this again next year.
Great. Thanks so much. It was a pleasure.